G'day everyone, welcome to New Tech. My name's Miles and it's fantastic to have you here. In today's video we're going to be checking out some really basic wiring techniques for FluidNC. So this is great for any beginners who are looking to start building their machines, or even people who have built it and wanting to know some other concepts. So let's get started. Okay, so I'm going to jump straight into kind of the setup I've got here, but later on in the video I'll also be doing a different wiring diagram, mainly for the Tinybee. So if that's something that you're interested, I've got some timestamps up here now that you can look at and jump to the part that you needed, but I'm just going to use this one in front of us now as just a basics on wiring and how to put the basics together, because when you understand the absolute basics or how something is constructed, it just makes so much easier to transfer that knowledge to other boards. Now, in the last video, I did show this one off here. This is a really cheap one that I got off AliExpress. You can use it. It does have some useful features on it. I won't be covering wiring up this because I'm not a big fan of it, mainly because it doesn't have a lot of features. It doesn't use a lot of the pins. It does have some, like a spindle and a mist output here, but it tends to be strange on how they put it together. It's not very useful for what I need, so I won't be covering this, but I have put the setup files. If you do have this one, I've uploaded it to the FluidNC wiki. You can go and check that out. And that reminds me that I forgot to mention in the last video, if you have a specific board and you want to find a little bit more information about it, they've started to collect a lot of wikis about these existing hardwares. Now, I showed this page in the last tutorial about the different boards that are compatible with FluidNC, and you can see here that if I scroll down, some of them have this like little wiki page installed, like a connection here that we can go and check out. So I'll go down and show you an example of this. I'll go to the Tinybee one that I will be looking at. So this one has a FluidNC wiki page. So if we go ahead and click on this, somebody's already gone through this and placed all the information here that you might need to set it up. So they go through all the different pins that are used on this board, some of the different schematics that are used, but also they have an example YAML file that you can copy and paste and set it up for yourself or change it as you need. So that's a really helpful resource that you can find on the wiki page for FluidNC. But let's go back to this one here. So I've uploaded my own. If I go and show you the uploads that I've done, this file here, which controls like the user interface, kind of went in and hacked it a little bit, changed all the colors, because I find the original white one is just a bit abrupt on the eyes, just being the glare from the screen, and changed all those colors to like a dark mode. I didn't really choose the colors as I was going. I just kind of made them up, but they kind of work nicely. They're appealing. So if this is kind of an interface that you would rather use instead of the white version, I've put the GitHub link down below. I've just made a repository. It's not linked to the original creator who made them. Sorry, so if there's any updates that do come from the original creator, that they won't be transferred across. However, I don't know if there's going to be many changes on this type of file in the future, but just be aware of that if you're going to install it, that won't come with any new features. But it's super easy. You can just replace it with the version from FluidNC, and then you can get back to the original version as well. So, and another way to get around this, you can do a plugin for your browser which changes the color themes for you instead of having to set it up manually and changing all the colors in the HTML. You can do that via your browser, but that means that it's only for that one device. If you then go to your phone, then it will go back to the white version. Anyway, so that's some of the things that you might want to consider as you're looking at these different user interfaces here. But I know that there are some people in the background dabbling with different versions of this as well, and hopefully one day that we can see some really positive changes through FluidNC and developments over time. So let's have a really quick look. Let's unlock the machine here. I've just put it back to the arm again, and let's go ahead and show you the user interface here. You can see that I've wired both of these motors up in parallel, so they're both using this motor driver to work. Now this one here is the TMC 2160. I've used these ones before on my MP CNC build. I really like these ones because they have the stealth chop mode, which means that they have that silent mode and you can't hear them at all. When they're moving, you can't even hear them moving at all, so it's quite nice on the ears. I mean, not like it's going to make much difference when you're cutting timber and making the high-pitched sounds of a CNC, But if you're using something or want something a lot quieter, these are a really fantastic option. Now these NEMA 17s are only, I think, 1 amp motors, so I'm only running this just under an amp, under 2 amp output, so I can feed both motors at the same time. The other ones I've got here is the middle one I've got on the y-axis. So I'm going to move the y-axis, and I'm going to show you one of the issues that I have with the y-axis. Now you can see that it is moving quite nicely, like the motion seems to be smooth, but in the background you can hear this kind of crunching sound. So I'm going to talk about why that's happening, but I'll just quickly show you the other one here. This one I'm using the STM5045 stepper motor driver. Now this one here I bought probably about 4 years ago. I can't seem to find these ones anymore. However, this one here goes up to 4.5 amps. This one here goes up to 5.6 amps. I know that there's many out there, many different versions available, even closed loop stepper motor drivers as well. I haven't had any issues with using these open loop stepper motors. I've never had an issue with skipping, but maybe one day if I ever do have those issues, I certainly update to the closed loop stepper motor drivers. One thing that I've got here is that even though these are 1 amp NEMA 17s, this one here is a 2 amp NEMA 17. This one's a 2.5 amp NEMA 17, and I didn't know that you could even buy anything really above like 2 amps. But anyway, if you're looking for something with a lot more torque, a lot more power, it's a lot heavier, but this one here, the 2.5 amp NEMA 17 is actually a really nice stepper motor. I got that one from AliExpress, and I'll try and put as many of these links down below as well. These two here are the same stepper motors, and they are NEMA 23s, and they are actually at a 4.2 amps each. They're crazy strong, and they can churn through a lot. They also have a 10mm shaft, which I quite like as well. So the nice large shaft just allows that more grip for the collet. I've also got here some really cheap limit switches as well. I've also got down here 2 voltage converters. Now these take 24 volts and turn them into a 5 volt. Now I've got 2 here because one powers a couple of these components such as the ESP and this little thing I'll talk about a bit later, and also the LEDs over here. Now getting back to the crunchiness that I was having up with the stepper motor up here, it's because that I've actually hooked this directly into my ESP32. The issue with the ESP32 is that it only has an output of 3.3 volts. And unfortunately, most of these stepper motor drivers need a minimum of 5 volt input. So what's happening is it's just not getting enough voltage for the input signal to output the steps correctly. And that's consequently creating this kind of crunch sound in the stepper motor driver. So if I show you very quickly what this one looks like, now I've set up this one in a different way. I've actually used like a step-up converter here. I'm going to go into that first up today and show you what this is and how it works and how it can ensure that you take the 3.3 volts up to the 5 volts, which these understand and are able to function with. So let me quickly show you what that looks moving. It handles the motion very nicely. You can see that if I turn it up, you'll see it spinning. It's I mean, I'm using this motor driver, which is quite loud. So anyway, that's the movement of that. But the way that I've stepped up the voltage from the 3.3 to the 5 volt, I originally got the idea of these little stepper motor drivers. Now this one here, I'll call them a very primitive stepper motor driver because all they're doing is converting the input from whatever you want to put it at 5 volt or 3.3 volt, and the output goes up to 12 volt. Now you may have seen these before. I quite like them because they have the little LEDs there. They show you when the signal is high or low. These aren't the best stepper motor drivers, however they do the job that I need for conversion. Now these ones here, if you want to use this chip, I've actually gone ahead and created my own kind of breakout board in a way that I've just used these screw terminals and used the ULN 2003 chip here as well. So the idea is that I think that it can have up to 8 inputs to 8 outputs, and what that does is allows you to should be able to control 3 stepper motor or XYZ axis independently just using one of these chips. Now, if you use it on this one, this only has 4 inputs. You can add other inputs, but then you have to figure out on how they're wired together, and it's just not worth it getting one of these little boards. So I suggest not getting these ones, but making your own little breakout board with these screw terminals. Now you can buy these screw terminals really cheaply from a lot of different places, and you can just wire things across themselves. So underneath this proto board, I've just soldered directly across for that little mounting board there. So let's have a quick look on how that works. So I've just taken the same signal output from the ESP32 and put them directly into the inputs on this side. You can see that this chip tells you which way the orientation is meant to go. I've got the little U shape or the little notch cut out there. So this side is your inputs and this side's your output. And you can see here that they just go directly from the output straight to the motor here. Now I'm going to put a diagram up on the screen just to better understand on how this is working. So you can see that this controls it through the ground wire, not the positive wire. So the way to wire this up, you'd have to daisy chain the positives and then use the negatives as your control wires back to this chip here. However, this stepper motor driver here, the TMC2160, because this can take a 3.3 logic input, this works directly with the ESP32, and you don't need to do any conversions for this one to be compatible. So it's quite useful to know that that can work, and if you're keen to try these out, that means you don't need all this extra stuff for these ones to be compatible, but you can get it up and going quite easily using that chip there. Let's talk quickly about the limit switches before I move into the user input. So you can see the limit switches I've used. These are a normally closed setup, so that means that when the limit switch, or there's nothing touching it, that there is a current always flowing through. Now that's going to this board here, which is my optocoupler board, or an optical isolation board. So the idea is that one side is connected to the ESP32 and that has no connection at all to the other side of the board. Now this side of the board then does the outputs to the limit switches alone. And I've decided to, and it should be done by using a separate power supply to power this independently from the rest of the electronics, because if something happens or if there is a short or something like that, you want to make sure you keep your separation. However, the other thing too is that this board can take, I think, up to 24 volts. So you can, instead of just using a 5 volt to control, at the moment I've just got 5 volts running through the limit switches, you can take up to 24 volts as well, which just gives that extra security as well with the voltage and keeping that nice and secure. So you can see there, if I go ahead and click the Z-axis limit switch, you'll see that the little LED there comes on and off. So I really like using these boards because they do have those LEDs on them, and it's just a really easy way to figure out what's going wrong with the machine. Has something gone wrong? Has a connection come out? So for example, if one of my wires had broken, you can see that the light's not on, so I can say, hey, look, I need to go and fix something before I continue on, which is so I quite like using something like this with the little LEDs. I can problem solve very quickly. So let me show you how all this works. So I'm just going to go ahead and click my home button for all my different axes. You can see that there's Z-axis starts off first, and it goes ahead and pretend the axis bumps it, releases it as it backs off, and then clicks it again, then heads over to the X and Y at the same time. You can change how this works for FluidNC. You can change them around, which ones go first, but I quite like this setup. This tends to work for most people. So let's hold down that one, and this one's going to go off. And I'll let go. Fantastic. Now they're all homed to their positions. Now if I do move these axes, I can move that one there. Now that's moved away from the axis, and I can also do other axes as well. So I want to talk now just very quickly about using multiple limit switches. Now, there's two ways of wiring these up. You can either do them in parallel or series. Now, if you don't understand that terminology, I suggest doing a little bit of research about how that wiring is different and how parallel versus series wiring works. Now, I've seen people use the stepper motors in a series connection, so that means it halves the voltage coming out. I'm not really a big fan of wiring stepper motors up in series. I rather do it in parallel and then just double the amperage out of here to make sure that they get enough power to put them at their full potential. But these ones here, you can wire these in both parallel or series, and they work in different ways. I'm going to be wiring this up in parallel. I'm not going to be showing you the series wiring, but it's quite useful for using the series wiring if you want auto squaring, which is not really auto but kind of forced squaring, but that's a concept for another day. Anyway, so I'm just going to come in here and add another limit switch into the mix. So the idea is, you can see the light's currently off, and I'm just going to plug that one in. You can see that that light will turn back on. So now that connection is created. So currently, well, the current is coming through here, through that wire, through the blue wire, and back into the red one, and completing that connection. So if I come along and click either one of these, you can see that they both trigger the limit switch off. This is really helpful if you have a dual axis where you want to make sure that if one side of the axis gets there first, that there's something triggered so something bad doesn't happen. And this is a really simple way on how to wire that up. So you can just kind of wire them in series, and it allows that the user to have multiple limit switches even if you don't have multiple inputs on this board, because there's not enough inputs. So let's move on to these user control input. So here I have a feed hold, a safety door, and a macro input. Now I've been trying to use the safety door input, and it's been throwing back a lot of errors of recent. It just puts the machine, it's like using an e-stop button, and it stops the machine and you have to reset the entire control board. Usually it should just happen that safety door is released. It should go back to normal and you can just press play again, but I don't know why my version's not working. Maybe it's something to do with the current setup, because I think I'm using 3.6.8 and there might be a slight error in this version of the software. So let's have a look at how I've gone about wiring these. So these are the LEDs in these are powered by the 5 volt, and this just has one pin going to the ground and one pin going to the positive. I'll show you what that looks like. So if I'm moving an axis, so if this is moving, the feed hold just pauses the motion, so allow the motion to slow down, to ramp down again to a pause, and then that will then stop the motion. If you hit the safety door at this time, I'm going to give it a go, but I might have to reset it. But I'm just going to come down here and show you, once I hit the safety door, it says check door. Now this should be spamming like crazy and constantly saying check door, but if I release this, then it comes up with safety door closed, issue cycles start to resume. Now up here you can see that the door machine is stopped, door still ajar, can't resume until closed. I have closed that switch, so that should disappear. However, I might just hit the restart, it goes back to idle. I should be able to move it. Yes, I can. Okay, so that's the safety door feature. And also I'll talk quickly about the last one here, is the macro feature. So the idea with the macro feature is that you can put in a macro, and I might show you very quickly on how you can get it going for yourself, but there's 3 ways that you can set up a macro switch. So the idea is once you click this button, then it will trigger a macro that's stored either on the SD card that you've got plugged in, or on the internal storage of FluidNC, or even put a macro on the YAML file. And so if you jump into the FluidNC, you can see that if I go to macros here, here's an example of how you can put it in your YAML file. You can put in your macro that you want next to it and put that as part of your YAML. And if I show you what my input looks like, so my YAML folder that I've set it up on, I've actually installed mine as a file that sits on my FluidNC. And you can see that I'm accessing the local file system, so using a $, then local fs/run equals z0.g. So I'll show you what that looks like on the local file system. So if I go to my FluidNC, if I go up the top to FluidNC and to my folder, you can see that it's triggering this file here. If I just download that, I might show you what's in that file quickly. I should have it up and going. This is the same version of it. It's not the same file, but same version. Now, all that happens in that file is G28, G91, 0, 0, and 20. And that's what's currently stored on the local file system of FluidNC. And I'll show you how the macro works. So if I've moved the axis, I'm just going to move a couple of them away from the 0 point, and it should return me back to 0, 0, and then up by 20. So I'm just going to allow that to happen. Now, you can see here if I click the macro button, okay, then it will follow that and it will put that macro into action there, return it back to where it's needed. So macros can be really helpful if you just maybe swapping over your piece of timber and you want the machine to go to a certain spot which is relative to the machine location. So this might be a good idea for it to pull the z-axis up and clear it out of the way of the material so you can quickly swap it over. So you can have those macros set up by a switch, which is super helpful if you don't want to have to fumble around on the computer to get it working. However, you can have macros set up as well as in FluidNC. So here's an example that I'm using. So this here just allows the same action to happen. However, it's using the FluidNC UI instead of this button down here. So they both do exactly the same thing. The way that I've set this up, if I just go to my editing, you can see that I've just put another file in there which says go to Z20, so that just takes it up from 0, and I've just labeled it differently and put in an icon to yellow, and that I've said is just stored on the ESP. You can also store macros, as I said, on the SD card and also on the setup file too. So I'll just jump out of that one. So that's referring to this file in here, which is this one here. So that's the macro file that I've put in there. And if I show you quickly what that looks like, that is this one here. So it's exactly the same G code, and it will just fire that one off as soon as I hit that macro button on either the switch or the UI itself. So in a nutshell, that's how macros can be set up, and that's how different buttons can be set up. And I think that it's quite useful to have a control panel sitting somewhere that you can access quickly. You can even put in like a resume button, so you can pause and then resume a file if you're in the middle of a cut. You can do many variations of different other buttons. So I suggest jumping over to the wiki, because this gives you an idea of what you can and can't do. You can also look at the input page too. So if I click here and go user inputs, you can see here that they have a whole lot of different ones. So that's the safety door one that I've used. It's the parking feature. The reset pin is there as well. You can do the feed hold pin as I've done. You can do the cycle or the start pin. That's quite useful. And then you can have up to 3 macro pins as well. You might be able to do more, but I don't know. I'm not too sure. I haven't really experimented with that. So the very last thing before I move on to other parts of, so wiring up the Tinybee, I wanted to talk quickly about the different connectors that I'm using. So over here, as you can see, on some of these I've used spade connectors. I said before that I use these Wago style connectors, and some of them are just directly wired in without any special connections on the end. They've just got the wires plugged in and ready to go. I have seen some people in the past go ahead and wire them in like this directly as wires. They work really successfully and they work forever. There's no problems. I've also seen other setups where they might tin these before they put them in, thinking that maybe holding all the wires together is going to be a good idea. It's actually a really bad idea. It turns them very brittle, and there's also a bad connection inside there because the solder isn't allowing all the different wires to kind of to mold into the screw terminal. So I suggest avoiding that one. However, you can also get other types of spade connectors which might fit in there, but I think logic comes into this. So when you look at a certain connector, always look and see. Here's an example over here. Okay, you can see here in these type of connectors, they have a round bottom of them and a flat top. So it can be completely up to you on how you're going to do this best to create the best contact with these terminals. Just check out what is the connection that you need to connect it to and how best can I secure it in there, which gives me the greatest surface area from using the wires to the connection that it needs to go to. Now, there was one thing that I forgot to mention earlier, is when that I've connected these buttons up here, I had a lot of issues with them being set up initially. Now, I've connected these buttons. If I go and show you my YAML file, so if I look in here, you can see where I've set up these controls here. The safety door pin is on GPIO 34. We also have the feed hold on 35 and the macro pin on 39. And some of you might be thinking, well, I can't see a macro pin on 39. So if I do look at this board here, there is no 39 on this board. This is actually pin 39 is SVN pin. You can certainly use that as an input, and I'll go show you quickly on the wiki where you can find some information about this. So if I go down the bottom here, it says ESP32 pin reference. So if I go and click on that, this might give you a better idea on which pins that you can and can't use. So this is a really good diagram here. You can see that I've used these pins up here. So 35, 34, and 39. Now, you can see that these are a different color. Now, these represent the input only pins, so these don't have like an input output. Now, unfortunately, as I believe, that inputs don't have a pull-up resistor. So what you need to do when you use the buttons on ESP or on an ESP, I suggest always using a pull-up resistor. Now, if you don't use a pull-up resistor, you can have a lot of noise, you can have some false triggering of buttons, and there's a whole lot of issues that you can have. The one thing with the board that I'm using, I've been able to hack it a certain way that I could create my own physical pull-up resistors just using the 3.3 volt output. You can see here I've just used a 10k ohm resistor. Don't get that confused with 10R. This is a 10k resistor. I've just bridged that from the 3.3 volt pin, so you can see here that the ESP is that last pin, 3.3. That means that little black terminal there, I shouldn't use a metal end, but I will, just in there, that's a 3.3 input, and also that terminal at the end is also a 3.3. Now, I've bridged on the outside there, just 3.3 to the 39 pin. I've also bridged the 3.3 to the 34 and then the 35. You can see that across there, and that just gives it like a more of a manual pull-up instead of using an internal pull-up, because these don't have an internal pull-up. Now, a pull-up resistor just means that it makes sure that that is adds extra current to that pin and gives it that constant high even when the connection is open or closed. There's always a voltage flowing through and creates that consistency when pressing those buttons. And that also is represented in the YAML file. So if you go through the YAML file, you can just see that I've just put these in as just the GPIO pins, but some of these you'll see that there is a little PU next to it. So for example, my limit pins use a pull-up resistor. That's what the PU stands for, and they are a constant as a high. So that means that there is a constantly a current running through my limit switches, which is between these two boards here, and even that as well on the outside, they're all at a high signal. That means that when this is triggered is when it goes to low, and that means that the limit switches can be triggered successfully, and also knowing that the pull-up there is also a bit of insurance that you're not going to have any false positive triggers. So the very last thing that I want to just quickly show you is that these boards here, if this is the way that you want to set your machine up, which is fantastic, go for it. Now, I purchased these boards here. Now, these boards have an incorrect print on them. Please don't get them confused. I did notice there's a pin here which is not a ground pin, but if you look up really closely to this board, you'll see that there is a ground pin just next to the 5 volt pin here. Now, that is incorrect. That is not a ground pin. So if you do buy these boards, don't get tricked that that is a ground pin, because if you look at the board, it's actually a CMD pin. There's obviously just an issue with the print that they've put onto these boards. So just keep an eye out for that if you ever do have these boards, that don't get confused with that pin there and wire them up incorrectly. Okay, so that's all I've got to say generally about the basic wiring concepts. What I'm going to do now is I'm going to jump over and I'm going to install the Tinybee and have a bit of a play with that. didn't take very long at all to wire this up, and I'm incredibly happy with this board and how it's been put together. So it only took me a couple of hours to rewire this one, and you can see that I've got a range of different motor drivers and different motors connected to it, so really just show the compatibility of this board. So this was incredibly easy to set up, so I've just gone and used the example that they have on the FluidNC wiki, and you can see here there's an example of the YAML file you can set up, and here you can see that everything's already laid out. You can just upload it and use it straight away. So this one's based upon an XXYYZ config. You can also do it as a 6-axis configuration if you want 6 different axes, so X, Y, Z, A, B, C, or however you want your setup to be. So here I'm just using the dual XYZ axis, and you can see that I've doubled up on my Z axis, doubled up on my Y axis. Sorry about the separation of the axis there, it's just easier for this motor to work on the Y axis. And you're going to also have the X axis as a dual motor there, and I've wired them up with different stepper motor drivers in different places just to show you what you can and what possibilities there are with these drivers as well. I've also left the limit switches as they were from the last setup just to show you that that still works exactly the same, and I've also got the same buttons over here as well. It is a bit of a mash of different things, but I hope that it answers your questions and certainly gets you to think about what type of things that might be right for you in your setup. So let's get started with the breakdown. There's a couple of things that I did change here from the original file. You can see here that I have got the control config slightly different. Now there was one thing to keep in mind if you're doing this control fig. So these are using pins 35, 36 and 39. So I think that this is the same pins that I used on the other setup earlier in the video, but you can see at the top here that the suggestion here is that using the TH2, the TH1 and the TB pins here. However, the TH2 pin is a SD card pin, so, and I think it says it up here somewhere or in the code somewhere, but I've used the TH1, the TB pin, and also up here which is the MTDT pin, and they're wired up for the inputs for this as well. So here I'm just using two DRV8825 stepper motor drivers, also to show you the compatibility as well, but just to power one motor each, and it's certainly possible to mix both external stepper motor drivers and also their plug-in drivers as well. Let's have a quick look here and see how it all works and the differences that I've added in. So on the original example config that they have for the Tinybee, the control pins here, they've used a reset pin, a feed hold pin and a cycle start pin. You can see that I've got something different. I'm still using the feed hold pin. So the other ones that I've changed was the cycle start pin, which is pin 39 at a low. That is my macro pin, and then I've just changed the reset pin and pushed that up to the safety door pin. Now I had a bit of a revelation in between creating the videos. The safety door pin, I was having a lot of issues in the last video about when I clicked it, it kind of just crashed the entire thing, and I realized it's because you've got to wait until you've stopped any movement on the machine, then go ahead and use the safety door feature, because I suppose if you were using this as it's meant to be used on a door that you open, you probably would wait till any movement had finished. So you'd probably hit the feed hold button and then the safety door would open, which means that that pin would be used to open up, do what you need to do, close the door again, and then resume the job. So it was a bit of a mistake on how it was meant to be used in the last one. So I'll show you today how it's meant to be used and how that kind of works as well. Let's jump over to the FluidNC here. So I've already got this connected up, and once again I've got this macro already set up. So if I go ahead and I can move these different axes, so this one here, this y-axis here is using this stepper motor driver, and this y-axis one is using this one here because it goes X, Y, Z, then the duplicate of X, which uses this one, I think, or this one is the two X's, and then the Y one, this is the duplicate, so these two are working together. So I suppose the thing to see at the moment is that if I did hit the Y, so you can see that they are moving different directions, and that's because that this input I've just flipped over, so this does go the opposite way, just to show you can do that. Let's move on to the X. We've got them both there, so this is using both of these. So this one's very comfortable in moving the 4.3 amp NEMA 23 there, so that's really capable and a very good motor. I was listening to it before without this one going as well, and that's incredibly quiet. And there's I think that I might actually use these type of stepper motors on my bigger machines just to see how they go. On the other one, I've also got my Z height one as well. So this one, I've got this one over here working, and also this one there as well, and you can see that they work very efficiently as well. So let's have a quick look at this in action. So I've just moved the stepper motor drivers. I'm just going to set the Y axis there, and then I click the feed hold. They both come to a pause and they ramp down to the pause. But if I did use that and hit the safety door feature, it would use it like an end stop and completely stop everything, and I would have to reset the controller entirely, but I don't want to do that. So if I did have this moving, I would wait till it stops. I can hit the feed hold to stop there, and then I can hit the door feature there, and you can see it pops up in this saying the machine stopped, door still ajar, can't resume until closed. And you can see here that it says check door, and now because I've released that button, it says safety door closed. You can cycle start. So I don't have a start button here. Usually on this side, for some reason, it sometimes comes up with a start button, but I'm just going to reset that part. Okay, so that works effectively, and also the macro button too. If I click the macro, you can see that these ones move as well, and they all move back to the original. So that's the Z20 and back to the home position as well. So they're going back to the original positions as when I started up this, and they're all facing the top. How nice. Okay, so everything seems to be working very efficiently with this setup. I really like this setup because it is so simple, and there's a lot less mucking around, a lot less components you have to deal with, because everything already uses certain pull-up or pull-down resistors as well. We also have those onboard motor driver options as well as the external as well. There's one thing that I'd like to add on to this board as we go through, and that's this little RS485 module. Because I use a VFD with my spindle, that this is a really great communications to the spindle, and it just allows that forwards and backwards conversation between the VFD and this board itself. So I think that if I was to set this up, I would take over some of the pins over here in the expansion board or in the expansion out pins, because there's a couple here that I can probably use to wire this up, but I think that's for another video. But that's probably the only external component that I'll need for setting this up. So I'm sorry that there's been a lot of conversations, a lot of talking in today's video about what I've got set up here. There's one thing that I didn't mention at the very beginning, is that this is all set up with a 24 volt power supply. Honestly, that's probably a little bit low for what I like to work at, because I usually work with the NEMA 23s on the higher torque motors. I would probably boost it up to 48 volts, but then you would have to figure out how you would power some of these modules, and some of the other modules such as these ones here are around 40 volts, so I wouldn't be able to boost it up to 48 volts. I'll just be mindful when I do use these in the future that I could only use 40 volts in the absolute maximum. But 24 volts works really nicely with these little tiny motors here. That's why I've used 24 volts today. And also this board is based off a 24 volt input as well. So it just makes this demonstration a lot easier today. If I was to boost it up, I would have a separate power supply for my stepper motor drivers that would be on a higher voltage, and then just the 24 volt. Maybe you could step down off one of those power supplies, or just have a completely dedicated one just for these and your limit switches and things like that. So I hope you have learnt something, and hope that this video has been helpful. I'm sorry that it's been a bit all over the place and explaining many different things at the same time, but there's just so much to explain and so much to talk about this type of setup. So I hope that you've taken something away and it can be useful for your own setup, or maybe even making your current setup a lot better, adding some buttons, and doing things like that as well. Now, if there are any questions that are specific for FluidNC themselves, what I'll probably prefer to do is jump over to the Discord and ask the team over there on specifics of FluidNC, just because you have a more of a knowledge base over there of people, the programmers behind it, and people who can give you that direct answer. But for things such as, you know, what type of end stops that you really like using, or some of the basics about wiring, I'd love it if you guys could comment down below and certainly help out other people who might be in the same boat as you, or passing on your knowledge in a really positive and productive way as well. So thank you so much for watching today's video. I hope that you've enjoyed it. Please like, subscribe, and all the rest, and I'll see you guys next time.